set up as known as baby giants because they've got that added 4 extra bytes. So they're not a giant frame like ISL because it's not a lot of extra. It's kind of a weird little misnomer to me, but it's a baby giant because it's got just 4 extra bytes potentially over the maximum transmittable unit. So something else with 802.1q is native VLANs. So the trunks are configured for a native VLAN. Traffic originating in the trunk on one side is a native VLAN that traverses the trunk does not require the tagging. So you might set default VLAN 1 is going to be the native VLAN for all .1q trunks, but in a lot of cases you'll statically set it to a different VLAN. In that case, since it's from the native VLAN, anything that traverses it, it's not going to add the 4-byte header. It's not going to have to recalculate CRC. It's basically just going to send it directly across from one end to the other. Because of this, though, both sides of the trunk need to be configured for the same native VLAN, or traffic will leak from one VLAN into another after traversing the trunk. So in this example right here, this side of the trunk is configured as the default of VLAN 1 is the native VLAN, but this side of the trunk over here on this switch, it's been configured as VLAN 3 for the native VLAN. So what happens is, since these are mismatched, VLAN a frame over here originating on VLAN 1 is going to go to the switch. It's going to broadcast out, cross this link as presuming that it's correctly presuming that it's the native VLAN of 1. But when it gets over here, it's going to be injected unintentionally into VLAN 3. So rather than this computer over here properly receiving the broadcast under VLAN 1, it's going to be leaked basically into VLAN 3. And I know specifically that I had questions about this exact kind of scenario. So make sure that you understand in particular .1q and the native VLAN. And if they present you with a question like this where the frames aren't getting to where they need to, that you look at the configuration of the trunk on each side and make sure that the native VLAN is set to the same on both ends of the trunk.
Is that by name or by IP subnet?
What's that now?
Is that by name or by IP subnet?
The native VLAN?
Yeah.
It's by name.
Right.
Yeah, and we'll actually, I'm almost positive on the next part when it goes into the configuration of .1q, it tells you how to name the native VLAN. But yeah, it's by the name of the VLAN, not because on the switch, even though we're going to assign IP subnets to this, it's not really routing or anything at a layer 3 level. So everything's going to be done based on layer 2 frames. So for the most part, configurations are going to be based on that as well. So it should be based on the VLAN name and number rather than the
so VLAN
the IP
1
address.
instance on the second switch would not get the message at all.
Correct, because when it gets over here, it's basically leaked into VLAN 3, so it doesn't even know that it originated in VLAN 1. It's just a broadcast address or broadcast frame that arrived on the switch and is already in VLAN 3. So, and since we're not a layer 3 device, we don't have any routing between different VLANs.
I could be missing the point here because I don't remember reading this section. So if it is that I'm just completely missing the point, we can go past it. But the native VLANs that are on the two switches, native VLAN 1 and native VLAN 3, aren't those also supposed to be specifically assigned to a switch port or a port on the switch?
Well, for trunks, all VLANs are going to be assigned to any trunk port unless you specifically prune them out. On the access ports, yes, you have to specifically identify, and unless you want everything to be VLAN 1, which is the default. For access switch ports, which is going to be a PC or something connecting there, you have to specifically identify which VLAN that port corresponds to. But on trunks, it's going to carry all VLANs. And with .1q trunks specifically, you have the ability to set this native VLAN. Now again, the default on that is also VLAN 1, but can be modified. So it's going to send traffic for all VLANs, but the native VLAN can be modified so that you can potentially have this leakage if it's not set correctly on both sides.
Okay, so there is actually a difference between VLAN 1 on the first switch and its native VLAN, which is the configuration for the trunk between the two
Correct.
switches. Okay.
Correct. Like,
that's what I was getting a little
okay, correct. Yeah, by default, it is VLAN 1 unless otherwise specified. But yeah, there is a difference between whatever the native between just being a native VLAN for a trunk and being particularly VLAN 1 on one switch or the other. Okay, cool. So configuring and verifying ISL and 802.1q trunks. If configuring for ISL, you must use all Cisco switches, and even then, some Cisco switches do not support ISL. So that again comes back to why I don't think you'll be tested really hard on that. I mean, it's still important. You should still a lot of times proprietary Cisco things end up getting adopted or melded into some kind of open standard later. Not sure if that's exactly the case with 802.1q and its relationship with ISL, but the fact that it's proprietary, it can only run on Cisco switches, but even then, I think it's like 2950s, it's very common Cisco switches that ISL will not run on, so must confirm all that, the equipment's going to support it beforehand, but to configure it, from global configuration mode, go into the interface of your trunk link. In this case, just like on the last slide, we're going to interface fast Ethernet 0/24. Once you're in interface configuration mode, the command is switch port trunk encapsulation, and then ISL sets it to ISL, obviously, and then a second command of switch port mode trunk. And remember, you're going to have to do this pretty much. Well, there's a couple of instances we'll talk about here in a second, but you're pretty much going to have to do this the same on both sides of the trunk because you want the configuration to match so that they're set correctly. If you want to instead set it for a 802.1q trunk instead of ISL, command structure is almost identical. In this case, interface fast Ethernet 0/ well, this should be 24 if we're going by the last thing as well, but in this case 0/22. Switch port trunk encapsulation .1q, and then switch port mode trunk to identify it as a trunk. And so we've also got dynamic trunking with DTP. Dynamic Trunking Protocol can be used to dynamically negotiate each side of a connection to determine if a port becomes a trunk. And this is actually specifically what I'm talking about when I mentioned that the configurations may not have to be exactly the same. My opinion is you should just set them up statically so you don't have to worry about this, but this dynamic trunking protocol basically allows you to set potential negotiation between each side of the trunk to determine what it is and what it isn't. So the 5 modes you have set are access, first of all, which statically sets it as an access port. It's not even going to take part in any kind of negotiation for possibly trunking that port because it's just an access port. There's going to be an end user device connected directly to it. You could also set it just statically as trunk. Statically sets as a trunk port and actively tries to negotiate the far end as a trunk with DTP. So it basically says, the side you configure this on, I am definitely a trunk. No one's going to be able to convince me otherwise, and I'm going to actively take action to try to make the other side also negotiate itself as a trunk. Then you can also set it to dynamic desirable. The port negotiates to trunk if the other side is set to trunk, desirable, or auto. And this becomes like an important, especially when we talked about the second one, this becomes like an important identifiers to when these things are going to happen. Dynamic auto, the port negotiates to trunk if the other side is set to trunk or desirable. This is the one I don't like because in my head when I hear dynamic auto, I think that it's automatically going to negotiate to become a trunk. But that's not true at all. It really doesn't do anything. The only way it's going to negotiate to become a trunk is if the other side takes some action first. So dynamic auto basically just sits there ready to become a trunk at any point in time, but it requires the other side to initiate that becoming of a trunk first. So the other side has to be set to either trunk or dynamic desirable to make this dynamic auto side work. So if you have 2 sides of a trunk that are both set to dynamic auto, it's never going to become a trunk because both sides are going to be sitting there waiting for the other side to say, hey, let's become a trunk.
They're both kind of passive.
Exactly, completely passive. And then non-negotiate, the the port permanently trunks but disables DTP. So that's also an option.